きやります。すみません。あ、これ、お願いします。Okay, we'd like to start the keynote session. Please come here if you are in the corridor, and please close that door. Okay, good afternoon, everyone. My name is Yoshinori Hijikata. One of co-chairs of IUI. I'd like to introduce IUI and interaction first. I think you are very surprised to see many people here. Especially IUI is a little bit small conference, so maybe IUI regular participants were surprised to see many people. Actually, we have 371 attendees from IUI and 640 from IPSJ interaction. And plus, I don't know the exact number, but several on-site registration people from interaction. So the total number is we have more than 1,000 people here. Thank you very much. At first, these 1,000 people get together at the same time, at the same place. However, it seems that someone go out for sightseeing, or I don't know the reason, but this is a little bit lower than my expectation. We prepare 2 rooms. One is here, Hitotsubashi Hall. This is the main hall, and you can enjoy live keynote of James Randi's keynote. And we also prepare satellite room. This is the same building, the 19th floor, and you can enjoy the scenery of Emperor Palace from here. If someone wants to see Emperor Palace from the top place, please also go to the satellite room. And also, we welcome questions after the keynote only in this room, only in Hitotsubashi Hall. So if someone there in satellite room and want to ask a question, please come down to main hall. Firstly, I'd like to introduce interaction for IUI participants and IUI for interaction participants. The formal opening ceremony will be held in tomorrow as an IUI opening ceremony, but this time a short one. I'd like to have a short one. IUI is an international conference of intelligent user interface. This is hosted by SIG-Chi and SIG-AI of ACM. IUI is one of the SIG-Chi conference series, like Makai, UIST, or CSCW. IUI is one of the major SIG-Chi conferences. The unique point of IUI is it deals with interdisciplinary area of user interface and artificial intelligence. I think there are 2 types of research in IUI. One is we exploit AI technique to user interface. AI techniques like machine learning, natural language processing, image or sound processing, knowledge representation, or knowledge reasoning. Another type of research, I think this is a new type of research, is user study of smart user interface. Example is recommender systems, healthcare system, wearable and mobile interface, multimodal interface, and tutoring systems. But this is my opinion, but we have this type of two types of research in IUI. But this is the history of records of participants. The records from 2010 in Hong Kong and 2018. Previously, we have 150 to 300 people in past IUI. The biggest one is 2011. It is held in Palo Alto. 303 people there. But this is my highest number before. The average is about 200 people usually in usual IUI. But however, 2018, we will reach the breaking number, the 371 as registered users. So this is my highest number and almost double as from my expectation. Now, I'd like to introduce the IPSJ interaction. This is the Japanese domestic conference on human-computer interaction. And this is held by IPSJ, Information Processing Society of Japan. This symposium is hosted by 5 special interest groups of IPSJ. SIG HCI, Human Computer Interaction, GN, Group and Network Service, UBI, Ubiquitous Computing, EC, Entertainment Computing, and DCC, Digital Creation. Interaction is the largest and the most competitive conference in Japan. The features of interaction is, this is the most prestigious oral session. As you see, usually interaction has more than 700 people. And also we have only one session, single session. So participants, presentators can present their presentation in front of many people. This is the biggest feature of interaction. Another feature is it gives us the largest demo session. As you see, we have many interesting and big demos in demo sessions. These two are the features of interaction. Interaction is a really important symposium for HCI researchers Japanese HCI researchers. Usually, Japanese researchers present a paper in interaction first and receives many comments from audiences. And after that, they go back to the university or company and enhance and develop the research more. And after that, they usually submit to major these conferences. Famous Japanese researchers like Daisuke Sakamoto, Jun Rekimoto, Naomi Yamashita, they will usually submit paper to interaction. After that, you can see it in SIGCHI or CSCW. So I think this is IP interaction is an incubator for Japanese researchers. This is the number of statistics of interaction. The registered participants is 614, and I think more than 100 people has been registered on-site registration. We have 20 oral papers. The acceptance ratio is 44%. The percentage is not so low, but however, Japanese researchers usually select by themselves and submit the paper. So the submitted paper is really good one. And we have demo papers almost nearest to 200. This is, I think, amazing number only in one country. And we also have 33 poster papers. The topics of this year is wearable sound device, touch displays, noise interface, remote collaboration, and robot, and social computing. The best paper this year is wearable. I don't know the exact title of English title. They title only Japanese. So, but this is my title: wearable sound device. From Jun Rekimoto, University of Tokyo. I'd like to thank the sponsors. I'm a general chair of IUI, so I don't have to thank to these sponsors. but anyway, this is the collaboration. Yahoo, Rakuten, SolidRay, TeamLab, NAC, and Marubeni Information Systems. These are the sponsors of Interaction. Thank you very much for all sponsors. And another more important, but this is the sponsors to IUI. Adobe, Dapra, Google, Rifle, IBM Research, Yahoo Japan, and Rakuten. Please give them a big hand. Okay, thank you very much. Now we have a shared keynote provided by Interaction and IUI. The speaker is James Landay from Stanford University. But the title is From On-Body to Out-of-Body User Experience. And the chair is Jun Rekimoto from University of Tokyo. And anyway, please enjoy this shared keynote. じゃあ、Rekimoto先生、お願いします。
So welcome again to the special joint session by CMIUI and IPS Interaction. I'm chairing this session, special session keynote, and I'm very happy to introduce Professor James Landay. James is a professor of the computer science and Anand Rajaraman and Banki Harinarayan Professor in the School of Engineering at Stanford University. He specializes in human-computer interaction. He is the founder and co-founder of the World Lab, a joint research and education effort with Tsinghua University in Beijing. And previously, Landay was a professor of information science at Cornell Tech in New York City, a professor of computer science and engineering at the University of Washington, and a professor in EECS at UC Berkeley. From 2003 through 2006, he was the laboratory director of Intel Labs Seattle. And also, he was also the chief scientist and co-founder of Netranka, which was acquired by Keynote Systems in 2004. And he is a member of the ACM Shikai Academy, and he's an ACM fellow. So please welcome Professor James Landay.
Okay, thank you. Can you hear me okay? All right, let's get this. Yeah. Gotta plug this back. Okay. So when I was asked to give this talk, I wanted to think about intelligence and interaction for IUI and also for interactions. And I was also asked to give a talk just in the last few weeks to a group about AI, and I thought, oh wow, I'm a human-computer interaction person. What do I know about AI? And I thought about it and realized that over the last 20 years of my career, almost every major system that I had created involves some piece of intelligence underlying the technology. So even though I think about things from a human-centered point of view, I'm often applying machine learning or AI technology to what I do. So today I'm going to talk about different ways that we've done interfaces on the human body, all the way to interfaces that are even off the human body. And I'm going to have a little emphasis on interfaces that use intelligence to help people with behavior change. So one of the keys to how I do research in my group, as well as how I teach HCI at Stanford, is to let students learn to find a balance between human-centered points of view and technology-centered points of view. Often in a computer science department, students purely come at things from the technology point of view, but I also want to emphasize design and make sure that students find design as an important part of their work, even within a computer science department. And in my own research, we try to find this balance. And I'm also interested in finding this balance with respect to different cultures. So specifically, I'm very interested in differences between Eastern and Western culture. I lived with my family in Beijing for 2.5 years and worked with a lot of folks in China and noticed how that could improve research for me by seeing things from a different point of view. So some of my research also has this cross-cultural point of view where we try to find differences that we may want to design for, but also how does that lead to new creative ideas. So I'm going to show you a variety of projects over the last few years, starting from 10 or 15 years ago, all the way to a paper that was just accepted yesterday. So what I have here is a map of the United States from 1990. And what this is showing is the percentage of the population that had a body mass index greater than 30. And what body mass index greater than 30 is this means somebody's clinically obese. This is where we start to see complications from that, including diabetes, heart disease, and other maladies. So this is the United States in 1990, and you can see in 1990, every state in the United States either had less than 10% of the people with a clinically obese, or 10 to 15% of the population. The states that are in gray, the Center for Disease Control just did not have data yet at that time. Now, in some talks, I like to actually animate through this over the years to show you what happens, because it's very interesting, but I think most people here can predict what happens. But if I show you 10 years later in the United States, we see that we've moved into this 15 to 25% range. I like to say, except for my friends here in Colorado, a lot of Olympic athletes training at altitude or something there to keep them green. But if you roll this ahead 10 more years, you see the southern United States leads in something here. And what we see is by this point, 1/3 of the United States population is clinically obese, okay? Now, over the last few years, the CDC has changed their methodology and they recommend to not show their new slides. I mainly don't show them because they change the whole color coding so it doesn't look good. But this at best is maybe leveled off. There's controversy in the research community, have we leveled off or not? Now you might ask, is this just about aging of the population? You know, a lot of people, they get in their 50s, you look at me, you put on a few extra pounds, is that it? Well, we see these same trends with children, childhood obesity rates, right? And those look like they may have just leveled off recently. So this has been a big problem. So the first project I'm going to show you is one from a few years ago, but I think some of the lessons still belong. This was a research project that was done at Intel Research Seattle when I led the lab. It was the PhD dissertation work of a researcher, Sunny Consalva, who's now a privacy and security user experience director at Google. And Sunny had the really nice observation that people were pulling their phones out of their pocket over 100 times a day. In fact, if we look at studies, you'll see numbers on the order of 200 times a day that people are pulling out their phone. And at this time, the phones were still pretty crappy. This was, you know, maybe the best smartphone you could buy in 2005 in the United States. But even for those phones, people are pulling them out for the obvious reasons, like just to check the time, to check their text messages, to check their email or calendar, or even play some primitive games. Today we know the games are a lot better and people pull them out even more. And so Sunny's idea was, could we take advantage of all those glances at the phone to change people's behavior in ways that they wanted with respect to their health behavior. So in her specific focus was, could we help people stick with their exercise goals? So if people had set goals to exercise more, could we help them by reminding them about how they were doing every time they pulled out their phone? So this here is what we call the UbiFit Garden. This was on the wallpaper or lock screen of the phone. Every time you pulled out the phone, you would see this garden. It started out at the beginning of the week with just green grass and a blue sky. But every time you walked for 10 minutes or more, one of these sunflowers would grow. If you ran or did an aerobic activity, bicycling, running, Stairmaster, one of these orange flowers would grow. And if you did strength training or stretching, one of the blue or white flowers would show up. We used intelligence in that we built this device here called the Intel mobile sensing platform. This was led by the late Gaetano Borriello, a professor at the University of Washington, and Tanseem Chaudhry, who's now a professor at Cornell. This was a small device that you wore on your belt. It had a sensor board with 10 different sensors, 3-axis accelerometer, 3 different kinds of light, barometric pressure. It had its own ARM processor and Bluetooth. And 3 times a second, this would send over Bluetooth to the phone saying, I think you're walking, 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 standing, running, walking, walking, walking. And then the software on the phone could smooth that into whatever human level activity was desired for the application you were doing. Now, when we built this, we did not think that people were going to walk around wearing these things on their belt. But you know, this was computer science trick 101, following Moore's law. We knew this stuff, if it worked, would eventually be built into your phones. And in fact, only a couple of years after this project, when the first iPhone and Android phones came out in 2007, our students were able to show they could do the same activity inference with almost as good quality, not as good. They killed the battery also originally, but that's been since solved on a phone without having to have this external device. So this was allowing us to play ahead on the future and see how we might use this in real applications. And today, this kind of software is built into all of your phones to be able to do this. But the question for me, from an interaction point of view, was could we change people's behavior by how we use that intelligent information? So what is the intelligent user interface? So Sunny's design of showing these flowers during the week, your flower garden would grow. If you had done what you set out to do at the end of the week, your garden would start to look really full like this, and then if you'd met your goal for the week, this butterfly would appear. This surprisingly small cue let people celebrate that they had met the goals that they had set out to engage in. If on the other hand, at the end of the week, your garden looked a little more empty like this, you might say, oh, I'm going to take my gym bag to work today. I'm going to go work out instead of go to lunch with my friends. Or I'm going to cycle on my bike to work instead of driving my car. It would allow people to kind of notice what they were doing and help those of us who are less good at paying attention to our behavior to have a little support for this. So that was the basic idea. How well did it work? Well, as the manager running the research lab and running this project and others, I thought that the intelligence, the smart intelligence was the real key to this. I invested a lot of my lab's budget in building that mobile sensing platform. Eventually, we built several hundreds of them and distributed them to the research community, spent a lot of money on getting engineers to take the research that we publish in great AI conferences and really make it work on an embedded processor for real where people could use it. There's a difference when you take something that's kind of good enough to get a publication and try to put it into a real system that people are going to be able to run for weeks or months and make it work. So we put a lot of effort into that. But you got to test it. So we ran a field study for 3 months with almost 30 people in 3 conditions. So one of the 3 conditions were really important. One was the full system. This means people had that device that did the activity inference on their belt, and they had the background screen on their phone that had the garden. There was another set of participants who had the background screen on their phone, but they didn't have the device on their hip. They had to manually enter all of their data. And we always had an interface for that because although we were able to automatically infer 7 or 8 different activities like cycling, walking, running, elliptical trainer, Stairmaster, etc., there's a lot of activities we couldn't infer. For example, in Seattle, rock climbing. Lots of people are climbing up rocks, or salsa dancing, or whatever, swimming. I wasn't going to spend the money to make this thing waterproof. So there were a lot of other activities. You had to have an interface to be able to edit and enter. So everyone had that interface, but that group did not have automatic activity inference. And then the third group, they had the smart device on their hip, but they didn't have that screen on the background of their phone. If they wanted to see what they did, they had to run the app, the one where you entered data, to see what they were doing. That is most similar to how most activity software is today. For example, I want to know how I'm doing. I log into, Google Fit or MyFitnessPal or whatever it is and see what I'm doing. Okay, that you have to think about it that you want to do it versus it always being there on ambient display like we had designed. So we ran this study at what I thought was the worst time of year to run a fitness study. We started the study right before the American holiday of Thanksgiving. So this means it's at the end of November, and the study ran until late January or early February. This is in Seattle. Seattle gets pretty dark, it gets wet, it gets cold, probably similar weather to here in Tokyo at this time of year. And previous studies show that people drop off on their fitness activities during that time of year. So at the time when we ran this, we thought, oh, this is a bad time to run a fitness study. In the end, it may have been fortuitous that we were forced to run it at this time. What we found is the participants who had the garden, whether they had activity inference or not, were the ones who were able to maintain their fitness activities during this period of time. And the folks who had to almost pull for it, who had to consciously think, tell me how I'm doing, those ones dropped off in the ways that prior research had shown would happen. So to me, the ambient display is really the key feature. This is not to say you don't want the smart interface, that you don't want activity inference. In fact, when we interview all the participants, whether they had activity inference or not, people felt that was an essential part of the functionality. They would want to have activity inference. And simply, this study is only 3 months. After a while, journaling all your activities gets pretty hard, and I think it would become even more important to have automatic inference over a longer period of time. Now, the reason I'm showing you a 10-year-old piece of research is to show that we don't really see commercial interfaces having learned from this. For example, the Apple Watch has a small ambient display. How many people here have an Apple Watch at all? Raise your hands. Okay, so you have an ambient display. There's that small little circle on the default watch face that shows you your activities, but it's so small that when you glance at your watch, you're not even conscious that you see it. It doesn't really take much focus. They have a different watch face that makes it larger. We'll show how we use this in a different environment next. So another area that I have interest in besides health is sustainability. So in another project we were interested in, what were ways that we could change people's behavior with respect to the environment? A big problem in the United States, besides the use of fossil fuels for heating in terms of coal, is also people driving their cars a lot and not using public transportation or riding bikes or other ways of commuting. So we were interested in how we might change that. So one interface we created was called the UV Green Transportation Display. The paper written on this was led by John Freilich, a graduate student I worked with who's now professor at the University of Washington. And the basic idea was, could we, in ways similar to UBFit, show people their transportation behaviors when they were green on the background of the phone? So in this case, if you carpooled, the tree grew leaves and eventually these pink blossoms. Now, if you ask people, would you like to be more sustainable or greener in your daily transportation? What do you think the answer is? Would people like that? Yes, 80% or more of the people say, yes, I'd like to be more green. But it's never the number one reason why you take a particular mode of transport. In fact, we did a study where we asked people that question when they took trips. So every time you took a trip, we noticed you took a trip, and then we popped up an experience sampling survey to ask, hey, we just noticed you took a trip, you took this mode of transport, what was your reason for it? And we found being green is 6th or 7th on the list. Being sustainable is low. Being convenient is really high. How much it costs is really high. Can I get other work done while I'm doing it is high? Can I get exercise? Those are all higher. So we show the ones that co-occur with being green here. So for example, if I carpool, maybe I save money. If I take the bus, maybe I save money and I can get some work done. And depending who's on your bus, maybe it's calmer. If I walk, I get exercise and I save money. So that was the interface there. And if you met your goal for the week, then these, just like the butterfly would appear in UbiFit, in this interface, this fruit would appear. Now this project I did in collaboration with Jen Mankoff, who was a professor at Carnegie Mellon at the time. She's now also at the University of Washington. And Jen's prior work said, oh, people for sustainability applications might be more engaged with them if they somehow connected with animals. So I designed another interface that we built at the same time, and I'll show it to you here. And this one was based on a polar ecosystem. So in this case, you start out with a polar bear on a little sliver of ice, like half this. And as you engage in green activities over the week, the polar bear gets a mate, there's more fish, there's more sea animals, there's birds, they eventually have cubs, etc. And then when you met the goal on that one, the northern lights appeared. So we did a study with both of these interfaces, half the people in Pittsburgh, half the people in Seattle. And again, now based on what we had learned from UbiFit, I thought, hey, the ambient display, that's the really important part. The idea that people are going to get this feedback in a visual form that kind of shows them how much they're doing is really important. In this case, we only ran a pilot study. I say it's a pilot study because there was only 12 people and it was only 4 weeks. 4 weeks is not enough to know about behavior change. But there were some really interesting results. One was several people wanted to keep using this device. Now you might say, what's the big deal? Well, by the time we ran this study, the iPhone and the Android phone had been out over a year. And by then, that phone that we were giving people was a piece of junk. And so anybody who still wanted to run it, it was kind of surprising because they had to give up their real phone to do it. And we also saw what I call behavior change in quotes. Again, it's not long enough, but we had people in Pittsburgh who said, oh yeah, I used to drive my car a mile to my friend's house, but now I'm riding my bike. The Seattle people were a little greener, so it was less interesting. But independent of those results, I in fact think an application of trying to encourage green behavior might not even be a good idea because the only people who would ever run this application are already green in themselves. So you're not getting at the population who needs it. But what was really interesting were the kind of qualitative feedback we got at the end of the study. People would say things like, oh yeah, I rode my bike today because I wanted to get to the next level of the game. Or at work, people ask me, what is your polar bear doing now? Or I took the bus to work so that I could get to the next part of the story. And we thought, what story? We didn't design a story. We didn't design a game. But people somehow saw story and game in this very simple visual display. And then the more that I've looked into this, we find that people have been, we've evolved actually to see story almost everywhere in the world. Story may have been, the way we communicated for millions of years or hundreds of thousands of years before other kinds of written language, etc. And so we're really story finders. We look for story. And it's said to me, could we use story as a way to drive longer term engagement in these behavior change applications? So you might say, well, what's the problem here? Why do you need to drive longer term engagement? Well, we know if you look at the research on fitness devices like Fitbits, how many people here have a fitness device, whether it's a Fitbit or a smartwatch or anything like that? Okay, several of you. Studies show that about a third of the people abandon those devices after 3 months of use. And 50% of them abandon them after 6 months of use. And I can assure you they're not abandoning them because they met their goal and said, I'm done. I've lost 20 pounds, or now I run 20 miles a week. I don't need this anymore. They abandon them because the novelty wears off, or in fact, those devices become a reminder of what you're not doing, which you thought you might do. And it's just a hassle. So how do we keep people using these kinds of things longer is one research question. So one idea we had, which we first developed when I was on sabbatical in 2010 and 11 at Microsoft Research in Beijing, was could we design a story and use a story as a way to engage people in behavior change in these kind of activity inference applications. And in fact, the story was originally developed with a designer named Luke Vink, who worked with me in Beijing, as well as some of the interns there at Microsoft. And then since I've gone to Stanford, we've picked up this project that had been dormant for a few years and tried to actually design the story out and build an application. So this is an early sketch that the students did of this character Zuki, who's an alien who lands on our planet. And Zuki's coming from a planet that's had runaway global warming, and Zuki's here on Earth collecting biodiversity to regreen his planet or her planet, because we don't know what Zuki is. And as Zuki goes through these adventures, you start to learn more about the story, about what Zuki's doing, and there's tension because the government's trying to catch Zuki, etc. So this is an early sketch for this. And then what we've designed is different chapters that go on the lock screen of the phone, as well as on your wallpaper, as well as in the application itself. And as you engage in your activities over the week, you move the character through that chapter, and if you meet your goal for the week, you move to the next chapter. So the idea is, if we keep it a story that actually has a story arc that we've designed, that has tension like in any story, will that be more engaging? And so we've designed about 13 weeks of this story, and you can see here in one individual week, maybe the character's moving in this balloon. This chapter's actually changed, but for every activity you engage in, a new colored bird appears on top, and then this gauge of altimeter kind of shows you how far you are towards your goal for the week. Now this has been much harder to design for me than when we did UbiFit and UbiGreen. Those were easy. We put them on the background screen on the phone, on Windows Mobile 5 or whatever people were running back then in 2005, and you would see it. The problem today is, I don't know about your Android phone, but mine, you tend to have a ton of these notifications all covering the screen. So what we've done with the design is we've tried to shove all of the things that you kind of have to see saliently. So for example, the birds representing new activities or this gauge are at the top of the bottom of the screen, because that's where the notifications in Android don't go. So you can see here it's on the lock screen, here it's on the wallpaper, and here if you actually run the app, which you may do to set goals or to see progress or to manually enter something that hasn't been automatically tracked by the Google Fit, is where it is. So we've built this application and we're about ready to release it. And it's really a research platform that we could ask questions about. So for example, the high level one for me is, do these multi-scene stories lead to longer engagement or more engagement in the app than we see with a single repeating chapter like we saw in UbiFit and UbiGreen? That's the first one that we're running a study on. The next one is this idea that I mentioned about sustainability probably being a bad idea for an app. Like I said, probably 20% of the people at most are interested in being green or interested enough that they would run an app to do it. But those are the people who are already green. So you're probably just going to tweak them a little. How do you get at the other 80%? And although medical doctors will tell you fitness is a very hard area, health and fitness is a hard area to work on, people are much more motivated about their own health and fitness than they are about being sustainable. So one idea is, if I gave you something like Who is Zuki, and it was mainly oriented towards fitness, but also if you did green activities, you would move the story forward, almost with that Trojan horse kind of idea of getting at sustainability, lead to more pro-environmental behavior than a green app by itself. That's a research question and another study to run. Another issue is, many of these behavior change applications try to tweak you on your value system. So they'll be based on things like, oh, you're really socially competitive, so I'll want to do, more exercise than June, so I'm going to compete with him. Or, oh, this is about money. He wants to save money. Or this person wants to save the whales. So the problem is usually they're just oriented around one such idea another idea here is, could we figure out what value system the particular user using our application has and have the interface be intelligent and adapt to that and try to get you on the motivator that works for you. So that's one we haven't yet designed, but we think works. The other one I mentioned earlier is this interest in cross-cultural feedback. So when I was on sabbatical in China, we ran a study with several hundred Chinese users and American users where we asked them to fill out a standard carbon calculator. And what we did then is we manipulated the feedback to be positive or negative. And what we found was negative feedback led the Chinese users to a larger pro-environmental behavior change than positive feedback. And for American users, the results were flipped, okay? So a question here is, should the feedback be negative or positive depending on culture? Now that study has some issues because it was based on self-report and it was only for a few weeks, so we don't know what would happen over longer term. But there is a belief that maybe you need different kinds of feedback. So what would that feedback look like? For example, in UB Green or in UB Fit, the flowers grow if you do something positive, like you exercise. But if you don't do anything, nothing happens. So in a negative interface, maybe the flowers start to wilt if you don't exercise or something like this. And so we've never tested that in a controlled study. And then from kind of an ethical perspective, what kind of data do people want to have tracked? And who can see this data? This is becoming more of an issue as we have these intelligent systems that are tracking our every move in terms of location or our physical activities. But as we're going to see in the rest of this talk and in other people's research here, we're starting to be able to track your mental health. I maybe can tell if you're depressed or not. Who's going to see that information? We have to start thinking about how that information is handled and who sees it. So another set of research that we've engaged in has to do with using UIs that go beyond just something on your mobile phone in situations where your phone doesn't make sense. For example, your eyes are busy because you're driving, your hands are busy, or you have gloves, or you're carrying other things, or simply because you're exercising and you find it hard to do. So some of the research we've looked at has looked at both input and output in these types of situations. Now, the context of what you're doing really matters for these interfaces. I don't know for you, but right here is a common scene that I see. Believe it or not, I've seen this several times in my 4 years at Stanford while biking around the campus, right? So, you know, students are riding around, they're looking at their phones. They usually don't have a helmet on, like my grad student there who was kind enough to demonstrate. You know, and there's accidents all the time. The doctors tell me every day there's somebody getting their jaw rewired in the emergency room because of these bike accidents. So can we pay attention to this context? For example, could we do output on a smart watch? So for example, in this situation, you see Kessler here is in a business meeting. He does a gesture with his fingers saying, hey, when's this meeting over? And he maybe gets feedback through vibration on his watch to know. Or he's asking, hey, what's the stock price of Google today? Or, hey, what's the Warriors score? Whatever he might be interested in. So this was the PhD dissertation work of Scott Saponis, who worked with myself and Desni Tan at Microsoft Research. Scott's now a researcher at Microsoft. He came up with this idea of, could we build a device that you would wear on your forearm and sense your finger gestures so that you could do this kind of scenario? So he mainly worked on the input aspect of this. And he published several papers at Chi and Wist on the idea. This was his second version of it. He first did it with a wired version. This was a wireless version. So he has EMG electrodes that you wear, and he sewed it into a sweatband. And we found he could get about 90% accuracy doing a bunch of gestures like this. So pinching with your fingers, or holding a mug with your fingers and pinching, or holding a bag that has 10 kilograms in it, and moving your fingers like that, maybe as you come up to your car and want to open the trunk. So we did this with about 90% accuracy. A couple years after we published these papers, a startup out of Canada made a very similar device, which you can buy now for $200 or $300, the Mayo armband. So this idea makes sense and will only get better over time. More recently, we're interested on the output end. So we have input you can do with your fingers. There's other people working on other kinds of input that I'm sure you'll see at IUI and Chi and WIST, places, UBComp. What about output? So for example, I'm on a long bike ride. Do I want to know, hey, you're 80% towards your goal for the day or the week or whatever it might be? Work with Jessica Cochard, who is a postdoc working with me, who's now a professor at IDC Hertlesa in Israel, worked on this idea, could we use today's smart watches that typically have some kind of vibration motor in them to transmit information to people? So we mainly looked at duration of rhythm and rhythm of pulses. Most of these watches don't let you even get at the amplitude, though simple amplitude things would help a lot. And we tried to design a vibration language that people could understand. And this was hard because, you know, I don't know, folks who have the Apple Watch, when you're driving with Apple Maps, it will tell you whether you're supposed to turn left or right using vibration. I can't even tell that. You know, I'm like, was that a left or right? You know, I don't really rely on it. So we wanted to see what could you transmit. So our goal for this was not too ambitious. We said, could we transmit the numbers, 1 to 10? Could we do 1 to 10 and get people to be able to understand 1 to 10? And what might we use that for in an activity tracking application? So after a lot of lab studies on this, we designed, an alphabet that I think is reminiscent of Roman numerals. So a 1 is a very short pulse, a 2 is 2 short pulses with a pause between them, and so on, all the way through 4. And then 5 is a long pulse, and then we start to put them together. So 6 is 5 plus 1, a long plus a short, all the way to 10, which is 2 long pulses. So that was the language that worked best in our lab studies. And we found we got over 96% recognition in a lab. So we essentially give you a random number and by sending you a pulse and say, hey, what number was that? After a short training session. So this video kind of showed, that's how it was in the lab. After that, we wanted to do a longer term study to see how would this work in the real world. So we did a study with about 30 people for a month, where every day we would send you a number once per hour, about 12 times a day, a random number, and then you would respond on your watch. You could either say, I felt it, but I'm too busy, or if you weren't too busy, you could answer what number was it, how confident you were, and what were you doing at the time. So here we see what that might have looked like in the study. So here Lydia's working, and she gets a pulse, and then she's going to answer the survey on this. So in this study, as I said, and you saw there, we get about 89% recognition rate. Depending if we send a pre-pulse letting you know something's coming, you'll get to 90 or higher. And in fact, I think that number is a lower bound because we're just sending you random numbers. In most applications, you're going to have numbers that are either increasing or decreasing in the application. So if you'd seen a 3 before, the next number you should see, if it's going up, is going to be greater than 3, and so you eliminate some of the possibilities. It works really well. It doesn't work so well in a couple of different situations. One is while you're running or biking, it's simply not strong enough for people to feel it, and we weren't able to change the amplitude. This was on a smart watch that was commercially available where you couldn't change that. But in any real application, you might be able to just do activity inference, detect you're running or biking, and make it a little stronger so somebody would notice it. The other situation it didn't work well is when you're talking to another person, because that uses the same part of the brain to be able to recognize the touch, the haptic feel, as well as count how many pulses it is. But in general, it works pretty well because guess what? About 80% of the day, people are just sitting, from what we found from our data, which is bad and good. Bad from a health perspective, good from we'll be able to transmit you information and you'll understand it most of the time. So how might we put these together? You might imagine an application where you're wearing a fitness armband that detects your gestures from your hands or fingers, and you might have vibration coming from your smartwatch. And so you might query it because you have a question, like in that meeting, or even here while running.
Gestures can be used to perform queries that provide application-specific information. Just Vibe supports discrete querying. While Jimmy is in a work meeting, he needs to find out what time his next meeting is at. Instead of pulling out his phone, Jimmy makes a subtle hand gesture, and his next meeting time is felt as a vibration on his wrist.
So it could be for that subtle hand gesture so other people don't know what you're doing, or simply because you're in an active situation and you don't want to pull out a phone, or maybe you don't want to use voice or wearing earphones or whatever, depending on your situation. So that's one area that we've been investigating. Some of the questions we have still in this area is, if you have an activity tracker that pushes that vibration feedback, so let's say every 10% of my goal, I get another number saying, hey, you're now 40% of the way through your goal for the week. You're now 60%. Is that better than something like a Fitbit where I have to push a button to say, oh, I've done 500 steps, or I've done 10% of my goal? We've run a study on this. We haven't yet submitted it for publication, but the results show that the polling type of interface, like the Fitbit, causes people to have a more negative mindset towards their health activities than when they started the study, versus people getting the pushed positive information. Only when you're hitting 10% goals, getting that information, we found, led to people maintaining their mindset towards their health activities. So that's a question we're still working on. Another one we're working on is, can we shape the mindset of users to cause them to perform more physical activity? So how might we shape it? So we might shape your mindset through messaging that we have in an application to cause you to be more engaged in physical activity. In the study we're running right now, we're actually lying to users. So we're actually inflating their step count by 40%. And 1/3 of the users were deflating their step count by 40%, and another set of users were holding it equal. And we want to see, the theory that a psychologist that I work with, Aaliyah Crum, is that people who have an inflated step count will feel better about their physical activity, and they'll actually engage in more activity than they would otherwise. Okay? If that result comes out true, it's not to say we should lie to people in their fitness apps. I would never say, hey Apple, hey Fitbit, hey Google, lie to people. That's not a good idea. But it's a nice controlled study such that if that result is true, then it really says we can shape mindset, and that mindset really does affect people's behavior with fitness technology. So that's what we're interested in that study. Now what I want to do is switch gears to interfaces that are off your body. A few years ago, the big thing in HCI was this idea of simple augmented reality. In fact, it was this idea of Google Glass. Google was really making a big splash, and a lot of people thought this was the future of interaction. And for those who work in augmented reality, I still think that is an important future. I think Google just picked the wrong applications first to really just upset people. But at the time, a designer I was working with, Luke Vink, and I started to think, well, what's another way of doing augmented reality that we might see? And one thing we've started to do in my research group is, instead of just going out and building technology for several years, we first make a vision video, a concept video, to explore that space and to understand what the issues are, and then to see, is it even viable and worth doing. So what you're going to see here is a concept video that Luke produced in 2014 when I was at Cornell Tech in New York, and I'll give you an idea of what's going on as it goes. So the girl's real, the drone is real, but the projection from the drone on the ground there is totally done in After Effects, and the shadows and things. So we wanted to create an interface that was around your body. So here she's looking at a map. Why she doesn't know how to get home, I don't know, but whatever. Again, this is not real. This was New York City. It was loud. There was trash blowing around from the drone. We like this idea of not having to wear anything else. Also, multi-user interaction is really nice. You don't have to register anything. They both are seeing the same augmented real world. So that works nicely. We had this idea that you could adapt to different surfaces. So hey, if you could track the hand and project just on the hand, that could be private information versus stuff that's on the ground. Or if you had a gimbal, maybe you could move the interface onto the wall. Makes it a little more complicated. And here she is, she's gonna run maybe with her friend who moved to New Zealand, or she's running against her pace from last week and seeing that interface at a distance ahead of her to keep her going. Now again, making the film kind of causes you to question different things. So one thing is we showed that film to a lot of people, and I had a lot of women who said, oh yeah, I want to go running with that thing, but I want it to be kind of telling people, don't screw with me. This is my protection, knowing that, you know, I'm being watched and this is safe. So people had different conceptions of what that interface could be. Then we started to get the feeling that there was interest in this interface, even though I think originally it was almost a dystopian view, that interface. It was trying to be as dystopian as Google Glass in some ways, and it may still be. We started to look at, well, what could we use a drone for? So can we take a step back? One thing we see at Stanford is a lot of tourists. Most US universities don't really have this. I don't know what it's like here in Japan, but in China I saw the same thing at Tsinghua and Peking University. There will be thousands of people lined up in front of the university each morning to go in there and take a tour. At Stanford, we see a similar large number of people. So we thought, hey, instead of being in a group with 50 people and a tour guide, what if you and your family had a drone that was your tour guide and it was customized to you? So it would know your language and could speak your language. It could know what you were interested in and only show you those things and let you ask questions of it. So we started to think about, okay, if we were going to create this, how would we do it? So we had this idea of the interface you saw in that video, but we wanted to understand how would people naturally think to interact with these drones. And we think the drones are coming, or quadcopters if you want to be less militaristic about it, but they're coming, and they tend to be coming in two different points of view. Either they're considered to be fully autonomous, like Amazon or JD.com is going to deliver something to your home, and it's just going to land there, or you're a hobbyist who wants to film things and you're flying the thing. But I actually believe a lot of the drones that are going to come into our lives are going to be ones that are semi-autonomous, but then we're going to interact with it. Whether it's one of these drones that follows you while you're running, but you have to tell it kind of what shot you want, or it's even that delivery drone that comes to my house and I say, oh yeah, bring that upstairs, or no, that's Henry, he lives next door, or oh, can you bring these shoes back, they don't fit. How do I interact with it? I don't want to have an app on my phone for every single drone that comes to my house, whether it's the pizza drone, the Amazon drone, the UPS drone, the DHL drone. You know, I don't want to have to go, oh, who am I talking to? When a person comes to my house, we just interact. So how are we going to do that? So we started to step back and we did this Wizard of Oz study that we published at UBComp 2015, led by Jessica, my postdoc, and one of my grad students, Jane E. So what we did is we had people
flying above a large
interact with the drone, and we asked them to tell the drone to do a specific task. So we had 18 different tasks, about 20 people, and this is what they did. We flew the drone, so it was Wizard of Oz. We didn't tell them how to communicate.
Stop. Drone, stop.
So for stop, people say stop, they put their hand up. For selfie, people did this. DJI came out with this a couple years later.
Something more specific from person to person.
You know, like circle around me.
If I had multiple quadcopters, maybe I'd be like...
This guy's like conducting
Some people became
drones.
very comfortable with the drone. Some felt like they were interacting with the pet.
Hey boy, here. Come here.
And some even interacted like it was a person.
Jay, drone!
Drone, can you take a picture of that palm tree, please?
Okay, so this last point was interesting. People started to interact with the drone like it was a pet. This guy just said, hey, can you go take a picture of this, please? He's talking to a machine and saying, please. So as we've seen with mobile robots, similar with these flying robots, people start to treat them like animals or people. We were interested was how much of this study were the results cultural. So we reran the study 2 summers ago in Shanghai, and we published this at CHI 2017, and we wanted to see, was there a difference with East Asian, Chinese culture from American culture, and what we found were some similarities and some differences. So we found some gestures were very similar. For example, telling the drone to come close to you, people beckoned it like this, or to take a selfie. Again, people do this thing for the selfie. And we found other things like, for example, in the US, stop, everyone went like this, and said stop. Multimodal was very common. What we found in China is slightly different for that.
That were more culturally specific.
Right, so this is a common gesture for stop. Like in the US, we'd say time out. So that was common. We also found we did not expect people to treat the drone as a person or animal based on different cultural reasons. We thought it would be considered part of the out group rather than in group. But as you'll see from this woman, we see her really referring to the drone like it's a person. I think you might not be so happy. If you want, you can try higher. She's talking to the drone, saying, you do this, do that, like it's a person. So then after all of this, we put it together. So 3 years after we made that original vision video, we built a version of what you saw in that video. So this now is not Wizard of Oz. This is not a video. This is real drone flying, doing real interaction.
We designed and built Drone.io, an intuitive and reliable interface for direct human-drone interaction. Drone.io allows you to communicate with the drone on the spot, without the need for radio controllers or other gadgets. The interface consists of a radial menu projected from the drone. The user can select items on the menu by hovering over the desired segment.
So you can see here the output of the vision system that's tracking the person's hand. You can see this is real. The drone's kind of drifting around here in the wind. And on the drone, we have a depth camera, a Pico projector, and then here we have an iPod Touch. And we have an iPod Touch rather than an iPhone just because it weighs less. So when you're doing this drone stuff, you're trying to shave off every gram of weight you can get. So here what you're seeing is from the depth camera, a structure sensor, and it's very easy for us to tell where the arm is and the gestures of spinning around this menu. And then we just notice when you flipped your hand horizontal and hold it, that that's a selection. And so we first did a study testing this in really a lab setting, because one of the problems with drones and these cameras today is you're changing batteries all the time, so this just made it easier for us to keep the study going and not have to worry about weather and wind and things like that. And so in this study, you'll find that people are able to do simple menu tasks. So here, he had to do 3 levels of menu. In this task, he had to find an icon. And then the third task was really like a real-world information-seeking task, like find the nearest food or the nearest bathrooms. And so you had to interpret the icons and also figure out how to navigate through this. So we found people were able to do all 3 tasks pretty successfully. They took a different amount of time depending which. So this was 3 levels of menu, this was 1 level, and that one was more. And then we ran an outdoor study with a smaller number of participants. You can see it's a semi-aerobic interface, like the person has to move around a lot. Again, we didn't really work on computer vision algorithms to do better tracking on the drones. The companies doing the drones are doing much better on that. In fact, since we made this, the drones have gotten a lot better at self-tracking. And we found, we did the first task and the third task, and we found people could do them. They were slightly less accurate outside, slightly slower, mainly due to that drift of the drone, but people really enjoyed the interface. So that was just showing, could we make that menuing system? And then we put it together to say, could we make this tour guide? So we made a demo where you could go up the engineering quad at Stanford that has 4 buildings on it, and this thing would point to the building to your, I guess, left and tell you which building it was. And then if you gestured, you could bring up that menu and ask for more information about the building or find out where the bathrooms were or where food was. I apologize for the photography here. This is me running around with my iPhone saying, we really got to capture this. It's not really a professional video, but just to give you an idea of what a completed system looks like. And oh, it's really loud. Really pushing it. So here she's got a map of the food places. or more
fun
information
fact.
about
Tell me
the
some
building.
fun facts you learned. Low battery? Well, we're going to land right after this, right?
And then she's
How about
going to
resume?
gesture to continue the tour.
And then we'll land, Tommy.
Okay, so again, much harder to make this than to make a video and make it really work with real wind and real people. There are like 30 people getting this demo. Another thing we've done in drones is maybe even crazier. I had one of my grad students, Parastu Abatai, say, what if you're in virtual reality and you could touch a drone and that would give you haptic feedback? And I was like, what are you, crazy? People are gonna get cut. You don't want to touch the drone. That's like the worst thing. She said, no, we'll make the drone safe. We'll put a cage around it. So she actually first made a safe to touch drone paper, a drone, and then she replicated the study we did in those 2 previous Wizard of Oz studies to understand how did people treat a safe to touch drone differently than one that wasn't. And of course, what do? They touch it a lot. So in this system, what's going on is you're in virtual reality, and maybe you're in an online shopping store, and as you touch these different dresses or coats, the idea is, could you actually feel that material? So we could put different materials on the drone and you can feel it. So here's a video showing the first cut of this system working. This paper has not been published yet, and we're still making revisions to the work, but this gives you an idea where it's going. So here, she's going to show you in about a minute these different scenarios. So maybe you're going to pick something off a shelf here in the store, and instead of it being purely virtual, she's going to pick the green item. This is what she's seeing. But when she picks it up, she's going to feel the real weight. She's picking up the actual drone that just landed in that position, and then she's going to put it in this box down here. In this case, she's feeling these jeans versus feeling this dress. So depending on which thing she's going to touch, a different material is going to face her, and so she'll feel something different in the virtual world, depending. So here she touches this, and it's a different material. And in this case, it's a little game, a spelling game. When the letters drop, you have to use your right or left hand. And if you get the right letter, you feel something. And if you get the wrong letter, you just feel air, like you've missed. So I don't think these are the best scenarios, but it kind of shows you the different ways the drone can be used for haptics. And now what I want to show you is more of a fun use of drones. This one literally was just accepted for publication yesterday, and this is work that I did with Hee-Soon Kim, who's from Sony here in Tokyo, who was visiting my group for a year, and this was just accepted to appear at DIS 2018. And his interest really was with dance, and how might we use sensors and drones in dance. So this is what he created, and the video you're going to see is him testing this with a dancer. So he was inspired by Godzilla movies. He said, hey, if you stomp on the ground, could everything fly up in the air? So as she stomps with her right or left foot, the drones go up. And here we have more drones around her. And this is really simple sensing and simple choreography, but again, getting these drones to fly where you want without them drifting off is harder than you think. But I think that's the first step in using this in more interactive, creative scenarios. So some of the research questions with drones, the biggest one for me, which I still feel unsure of, is what are the compelling applications where humans are going to directly interact with these drones? Beyond search and rescue, most of these scenarios for me are like, okay, is this important? Should I work on it? Should I leave that to industry? So if you have great application ideas, let me know. Another one is, how do we leverage multimodal input in these human-drone interfaces? So we found that when we did those gesture elicitation studies, we didn't tell people to gesture. We didn't tell people to talk, but those are the ways people thought to communicate with the drone, and multimodal interaction was very common, and in fact, in the Chinese study, even more common, and people in China were even more expressive with their body. So if they told the drone to go down, they would move their whole body down like that. So how do we best design for that? And then, can we make drones that are effective in virtual reality as a way to give haptic feedback? Some people have done things with robot arms, but we think drones are a lot more flexible because they can move anywhere in the space, and you can have multiple of them move in and out with different materials. So we're working on that still. So the last project I'm going to leave you with is also off the body, and it's really about smart environments. And it's really a reaction to the idea that people feel, at least in America, but I'll bet very common in Japan and other places, a lot of people are overstressed. A lot of people and students especially are distracted. People are wasteful. They're unhappy. And a lot of people feel isolated in their work or school environments. And our observation about this was people spend 87% of their time inside of buildings. And in fact, the way buildings are designed affect you in all those different ways. They affect your wellness, your mental health, your productivity, even your feeling of belongingness. Yet those things don't really come into building design a lot. I like this quote from Churchill. He said, "We shape our buildings, thereafter they shape us." Okay? And this really inspired our team to think about, could we be smarter about how we shape our buildings, and in fact have them be more adaptive even after they've been built? So we know, and architects know, that for example, daylighting leads to increased productivity. So some countries even have rules that you have to have daylight near workspaces. We know that greenery improves people's mood. We even know that greenery leads to people recovering more quickly in hospitals if they can see green outside their window. Again, this has led to some zoning laws in certain places where you have to have greenery that can be seen. We know that reducing noise reduces stress. This is a big issue with many of these open floor plan workplaces that are all the rage these days. So again, we're inspired by this idea, can we thereafter shape our buildings because they're shaping us? So this is a vision video from a summer ago that Stanford undergraduates working with me created. Again, before we create any technology, let's try to make a video, because writing the script makes us think through some of the problems. Making the video and seeing it and showing it to people gives us feedback and tells us what's crazy, what's good or not. So again, this is just a possible vision of the future workplace. But it requires a lot of intelligence to do any of the things you'll see here. So can we have images that are on walls or glass? Can we have the dynamic paintings? Can we have temperatures that react to different people's preferences and save energy? Everyone knows that most buildings have been designed for men and not women in terms of temperatures. Actually, men at 165 pounds in 1955. Can we have adaptive sound, active noise cancellation? Can we notice people are stressed out and adapt their spaces to that stress? We've done a lot of work on automatic stress detection. Can we add greenery? Can we change the lighting? Can we change the sound? And can we do it in a way that's not creepy or else nobody would want it? Can we use interactive artwork to change people's behavior with respect to maybe taking the stairs and not the elevator, or meeting people they haven't met, or simply to get people to go outside and get out of the building in the first place. So again, those are just ideas. We haven't built this. These are things we were thinking about working with civil engineers and psychologists. Now, why do we think some of this vision will come to fruition? We think that buildings of the future are going to be these hybrid digital spaces. They're already having all of the sensing built into the building, mainly for environmental and security purposes. But can we use some of those same sensors as well as the sensors that we're all bringing and wearing as a way to make buildings be more adaptive to our wellness or our other needs? We know there's going to be displays everywhere. You already see this in modern companies as the prices of large displays drop. Every time I go to Costco, I'm like, really? You can get a 60-inch screen for $300? You know, it's just incredible. And eventually, they'll be low-powered as well. Whether they'll be in a smart conference room like this, or they'll be on glass walls like in this Microsoft Vision video, or there'll be interactive art displays down the walls as you walk down a corridor like this envisionment. We might imagine, how could we design these displays to actually change behavior in positive ways? So what we need is sensing and actuation, where the actuation could be visual, or it could be auditory, or it could be controlling the sound or temperature or a variety of other things. So this is sensing to infer the human state, and then actuation to shape behavior. So imagine we have a kid's classroom that adapts the characteristics of the light and sound, et cetera, for when the kids are doing art versus maybe when they're doing math. Maybe it should be different. Or maybe the classroom adapts to this kid here who needs less distraction because he has ADHD. Maybe his sound characteristics will be different versus this kid here needs something to keep her perked up, and she actually needs some more noise and sound. So maybe even individuals might have a different reaction to the same space. Or as we showed in the video, can we detect stress in workers? People have already published where we can detect your stress through a keyboard or a mouse. We recently published a paper where we can tell your stress level just by how you're steering in a car. So interactions with common everyday objects, we can already detect stress levels. But what do we do with it? So in this case, do we adjust this guy's sight, his sound and light, or again, is that too, paperclip creepy in that we want to just make it easier for him to notice this is happening and have him take control? That's where the UI design comes in. How do you make this work right? And might we have digital displays where this looks like a piece of artwork, but it's actually these fish are swimming around depending on maybe how much exercise my team has gotten. So, maybe my team is this fish and he's swimming quite slow. So maybe that encourages us to have a walking meeting as we have our group meeting that day. So how do you design this for buildings? It requires a lot of work on the intelligence of sensing and understanding people's state. And then it requires a lot of design. How do you design these in a way that people would find it useful and not consider it, oh, that's the NAG building, I hate going to that place, right? That's where the design trade-offs and tests and things need to happen. And again, this is really an early stage project that we have not actually built anything. It's just something we're thinking about. And I'm going to conclude with that, and I thank you for your time.
Any comment, questions, and student volunteer? Yeah, okay.
Thank you very much for your very interesting talk. I have a question about your drone human interaction. We have a similar project, but the main problem is that in most countries there is legal limitations on using drones in populated areas. Have you considered these kind of issues in your projects?
Yeah, so the question is, have we dealt with regulation in terms of where you can use drones? So, we have regulations in the United States about drones, and even on the Stanford campus, we have more regulations about what we can run. So I think those laws are going to change as the drones become work better. Right now, they can be dangerous. In fact, when we ran that study in China, we originally were in Beijing. We tried to run it until we realized you can't actually fly a drone anywhere within the first, I think, 5 ring roads of Beijing. Drone just wouldn't take off because it's all restricted airspace. That's why my students had to go down to Shanghai to run the study. I just think those are kind of early stage things. This is a new technology that people don't know how well it works, and they see areas for danger. And in fact, when we have a ton of those drones flying around, there's going to be issues of airspace and noise and all this other stuff. But I usually look at my research at a much further out view. So, you know, I see it more like 10 to 20 years. So what happens when that drone is this size, like a hummingbird, and it's really quiet and it goes really long on a charge versus the things that we have today? And I think the world will be different at that point. And now that world may never come to pass because of regulatory reasons or others, but if you just look at how these drones have been progressing, from whether it's DJI in China, that's the biggest company doing this, they're just really on an incredible curve of making them better and better and more intelligent. And so I think we're going to see them in our lives. The question is how much. That's what I think is just speculation at this point. I don't know. But I think we better get better applications than just delivering you something from Amazon. That's not good enough for me. So again, application ideas I'd love to hear. There's a question over here.
Can you hear me? Oh, perfect. Thanks a lot for the talk. Really interesting. Just a thought, maybe getting your thoughts on sort of the multimodal interaction aspects of that and sort of the push for natural user interfaces. And you mentioned speech and multimodality alongside with the sort of haptic interfaces. We are still struggling with speech, and I say that as a speech researcher. It's natural, but we're still struggling. Vibrations are a bit easier to handle, but it's something so unnatural about using them as an interaction modality. Nothing vibrates naturally. Where do you see this push in kind of merging these things? Should we just chase anything that's natural? Should we hope that we adapt to things that maybe are not so natural, but they are easier to handle, like vibrations? Where do you see the next few years in kind of the space around this?
Have been around as a vision for 20 or 30 years. Multimodal UIs going all the way back to the late 70s, early 80s. I think the real mistake in these interfaces is to think, oh, one of these things is best. So often my speech recognition colleagues have said, oh no, speech is gonna be it. And you know, they've been telling us that for 40 years. First of all, it never worked. But even when it does work, there's these issues of where speech doesn't even make sense. Where, you know, for example, using a speech interface right here while you're in my talk would not be a great thing. So I think the key to these are multimodal interfaces that can use a variety of these channels and move smoothly between them. You know, so, you know, right now the latest is everyone's got their home device, whether it's Alexa or Google or all the 20 devices in China. And so people think, oh, you're going to use just that thing. But I think that interface is really horrible. Try working all day where you just talk to something. You will be tired and worn out really quickly. And it's not the most natural channel. What you really want is something where I say, hey, I want to order another pizza. And then it throws up on that display I have over there the pictures of the pizzas you have ordered over the last 3 months. And then you say, yeah, that one. Again, it's multimodal. It's taking advantage of multiple, and it lets me move depending on what I want to do. If I want to just talk to that machine, I talk to it. If I want to point at that display that I happen to have, fine. If I pull out my phone, I can use that too. And so the hard part is, how do I design an interface that's got to run on any device that you might bring to the environment and adapt across them? That becomes a harder engineering and design question. But I think that's the more natural interface that people are going to want. Use whatever I have however I want, not, oh, you must talk to this thing and that thing you must gesture at and that thing you must kick. You know, it's going to just be fluid, and that's where the research got to go next. And you already even see this with like the Echo Show, which has a screen and voice, works, in my opinion, a lot better because you can get feedback, for example, that's not only by audio. And so that's just the first. We'll see, I think the next 3 years, we're going to see this huge explosion in more multimodal interfaces, and then the cross-platform interface, which is, again, harder engineering because to get that to work right requires the people like Google or Apple, the people who control the stack, to be able to put the technology in there to do it. That's why you will see less of that fast. Until they do it, many of us can't really do it other than in research. But I think multimodal really is the interface that it will be, whether I'm wearing my augmented reality glasses or whether I'm pulling out my phone, that's going to be what it is, but it's still taking time to get there.
Yeah, so thank you for the talk. So since almost all Japanese HCI researchers here, I want to ask some more abstract questions. So yeah, so whenever we present HCI research against more technology-oriented people, we often get similar criticism. You know, where's the core technology? Or where's a difficult problem, technical problem to solve? Or this is just random applications. Where is a core contribution? Or yeah, something like that. And yeah, I often get this problem when hiring an interview or funding the interview and so on. And yeah, so my question is, have you ever experienced this kind of difficulty or not at all? Or if you get this criticism, how do you, argue against this criticism? How you justify the value of HCI research against these technology-oriented people?
Okay, so that is an abstract question. So first of all, it's humbling to know even Takeo's work gets criticized. Of course, my work gets criticized, and I was, my whole career, even as a graduate student in the 90s at Carnegie Mellon, which was the best place, I think, doing HCI, you had to defend, like, why was this computer science even, right? And I was the first HCI faculty hired at Berkeley. Again, it was like, why is this computer science? So I've had to argue that question my whole career. I'm kind of sick of arguing it. I would say, yeah, I've succeeded, yeah. So, I mean, one thing that I think has really happened that's changed is the rest of the world has noticed how important user interaction and design is to the success of their products. So, the fact is, in Silicon Valley now, when people start up companies, the question is, who's your chief design person? That used to not be a question. It was, you had your technology and you had your business person, and that was it. Now, a lot of companies, design is a key contributor. So that's helped a lot in terms of justifying that. Another thing that's justified it, I don't know what it's like here, but for us, the students. So at Stanford, the largest major at Stanford is computer science now. Over 20% of Stanford undergraduates are computer science, and Stanford's not an engineering school. It has engineering and science, but it has humanities. So this is a huge thing. And of those students, we have different tracks. So there are things like graphics and theory and systems and HCI and AI. Until this year, for the last 5 years, HCI has been the most popular track. So AI just passed it barely, which is not surprising. And a lot of those students do AI and HCI. So the students kind of are voting with their feet saying, hey, we see these skills as things that are going to be useful to us in the world. So there may be still some old computer scientists out there who think, hey, I don't see enough math there, so therefore it's not computer science. But I think enough people have realized that a really hard problem in making any computing system work is the people part of it, the interface part of it, and there is research to do there at whether it's exploring new ideas, which I'd say people like Jun Rekimoto and you have done work here in Japan, where I'd say it's sometimes 10 to 20 years ahead, and then 20 years later it's like, oh yeah, that's what Jun Rekimoto was doing 20 years ago. So some people are exploring the future. That's a lot of what the kind of work I do. And then others are exploring what are the techniques for design or evaluation that we need to create for industry to be able to do a better job. And they're producing tools that industry uses just as much as if I was a programming language researcher creating a new programming language that was somehow better. They're creating new technologies that others will use to make interfaces better. So there's definitely research there. I actually don't think, maybe you're still having this conversation. I feel like I less have that conversation in the United States anymore. HCI is a legitimate part of computing, and even at a place like Stanford, which I would have said was kind of a stodgy old department, they've hired HCI people. They're totally open to hiring more of them. So I think we've passed that barrier. It's still going to be there a little bit, but I think it's nothing like it was 20 years ago. Mm-hmm.
Hi. My question might be a little bit less abstract. So in your examples, you mixed different strategies. Some of your examples showed instrumenting the environment in the UVCOM tradition, some instrumented the human in the wearable tradition, and some even immersed people in totally synthetic worlds. This seemed like a pragmatic mix, but maybe you have some general considerations or some general take on this?
I would say I'm pragmatic. So I would say do what works. You know, I think wearables work really well for being able to detect things about our body and maybe giving us some feedback. But on the other hand, they have the disadvantage of you have to wear them on your body. So, you know, there's the design space has lots of disadvantages. And so for me, I don't have a kind of religious intent to say I'm only going to do wearable computing or I'm only doing you know, computer vision as input. As an HCI person, I kind of don't care. I just want stuff that works, and I'm willing to try different things and see what goes and explore a larger space. And I think, you know, that's an advantage of being senior and not having to prove anything to anybody and be like, oh, I'm the best at X. But yeah, I don't really think any of us could predict, you know, oh, that one thing is going to be the thing. But I think that's just preference. Different researchers may just go, I'm going to be the best person at this thing and only do that. I tend to just kind of wander around. And also my students drive a lot of it too. What the students are interested in and excited about, I'm usually willing to let the students go down a path, right? The whole drone stuff, I'm very uncomfortable with still. You know, as I've maybe indicated, like I'm still looking for like, is this worth doing? I might drop it because it doesn't kind of meet my idea of only working on things that help the planet. But on the other hand, that came out of a student, Luke, who was working with me, who was really interested in that vision. So that's what got it started. So sometimes just following the students leads you down different technologies because they have their own interests.
Thank you for great.
And I'll be glad to stay around for those who have more questions too.
Thank you for great talk. Sorry, my question is not abstract. Yeah, I love the idea that ambient display change and affects users' behaviors. However, I'm not still convinced why ambient display can change users' behavior. Can we explicitly design users' behavior to take more desired behaviors or actions?
Okay, so let me see if I understand you. You're not convinced that the ambient display changes behavior?
Yeah, yeah. We know ambient display change users' behavior, but I'm not still understand. I don't still understand
why. Okay, so I'm not sure we know the exact mechanism because we haven't explored it. But I think the theory is that people who are better at managing their behavior are better at reflecting what they're actually doing. So they remember, oh, how much they've exercised or what they've eaten and how much they've eaten. And I think the idea is that the ambient display is kind of giving that information to a person who's less good at tracking it themselves. And by seeing it over and over, that's kind of unconsciously making them better aware. So they see those flowers and know hey, I've done a lot of exercise this week, and have also positive or negative feedback to themselves to know it. I think that's what's going on, but we haven't really delved into going, what exactly is the mechanism, and prove what the mechanism is. So I agree with you. You should be unsure. I'm not sure. All right. Thank you.
Okay, thank you very much.
Thank
Again.
you.
So let's give a big hand to him, James. So, do you want to say something to it?
Okay, we finished the shared keynote session. For IUI participants, we will have a reception tonight. I think you have selected the reception place from 3 options, and you already have a ticket for that. Please go there by yourself. I have passed the map to the restaurants, and go there by yourself. Student volunteers stand at the important intersection. So please see our, those student volunteers have a sign on the band, on the arm. So please go by yourself. But if you are not sure where you are there, but please ask surrounding people. I think they will kind and help you to go there. Thank you very much. And we will have a closing ceremony for interaction. So your participants could please leave this place and go to the reception place.
Hey, how are you?
はい、では IUI の参加者の皆様は会場から退出してください。なんかやる？
We haven't really explored what's the right way to design stories, but we've designed one story, and we're trying to test, even if that story's not a great story, it doesn't have an effect. And then we can imagine you're going to want a lot of different stories, so we can imagine user-generated stories or other ways of generating stories that might work for that. Right now we designed a story, and we haven't tested it yet, so we don't know. It doesn't work. It's still just theory.
We are very sorry, so we need to use here.
Okay, for the next session?
Yes, yes.
Okay, let me move out.
Thank you.
Sure.
I'm not a very professional person, but the concept of PCI, I think that when I see organized
あ、そっち。いや、こっちはい。はい。あ、ちょっと。先にやられたのかな。
もう今やって、今やってください。あ、なるほど。
インタラクション参加者の方、ぜひ、後ろの方じゃなく前の方、まだ空いてますんで、前の方詰めて座ってください。受賞しちゃうかもっていう人は、ぜひ自信を持って前の方に座ってもらえれば。ぜひ、学生さん、昨日、指導教員の方がいらっしゃらないこと、指導教員しかいなかったということも昨日あったということなんで、ぜひ、学生さんも含めてですね、中の方で待機をしててもらえると、写真が撮れるんじゃないかと思います。じゃあまずは、総務の方から忘れ物の案内です。
すいません、表彰式の前にちょっと、忘れ物の案内します。今総務の方に届いている忘れ物として、メガネ、パソコンのケース、で、傘のカバー、なんか帽子、茶色っぽい帽子、あと腕時計、で、あと、立命館大学の方の領収書が届いています。田中正史さんですかね。はい、学生の人の領収書ですね。あと、多分これいらないと思うんですけど、ミューチケットっていう名古屋の名鉄の指定券のなんか、ひょっとしたら領収書として使えるようなものがあるので、はい、もう終わってるやつですね。はい。なので、ちょっと心当たりのある人は、前の方に置いておくので、私のところまで取りに来てください。総務からは以上です。はい、じゃあ、私前に座ってるので、そこに。ありがとうございました。
じゃあ、よろしいですか。それでは皆様お疲れ様です。ここでクロージングと、その前に本日の一般投票および APC の、インタラクティブ発表賞の表彰式を行いたいと思います。まず得票数ですが、おとといは186票投票いただいてました。そして昨日はちょっと下がってしまって166票でした。では本日はどれぐらいだったでしょうか。増えたか減ったか。答えとしては昨日よりは増えました。ほぼおとといと同じぐらいなので、かなり多くの方に投票いただいたと思っております。皆様ご協力ありがとうございました。ではまず、投票結果が上位でしたけど残念ながら賞に届かなかった、発表について、お知らせします。こちらの3件になります。非常に接戦でした今回は。はい、皆さん拍手をお願いします。では最終日の、インタラクティブ発表賞一般投票の方を発表いたします。今回は、3件受賞がございます。受賞されたのは、こちらの発表になります。 3B の24の、方、3B の39のエモーションの方、あと 3C62 の水面反射を用いた空中像とのインタラクション、この3件になりました。皆様拍手をお願いします。それではですね、表彰式の方に移りたいと思います。まずですね、ラポトーシスの方の、発表をされた、方、最大3名、前の方にいらしていただけますか。いらっしゃいますか、まず。いない？いらっしゃいます？あちらの方に、ステージ向かって左手の方にお願いします。どうぞどうぞ。
もう一度いきます。はい、インタラクション2018インタラクティブ発表賞一般投票、孫四亜様、橋田様、上岡様、貴殿が本学シンポジウムインタラクション2018において発表されたラポトーシスものの自律的でサステイナブルな再生服を用いたプロトタイピングは来場者による一般投票で好評を博し、今後のインタラクション研究に一石を投じうる魅力的な発表と認められました。よってここに表彰いたします。平成30年3月7日、インタラクティブ発表委員長山本剛志郎、おめでとうございます。
本当にありがとうございます。まずそのコンセプトにみんなすごく共感していただいてすごく嬉しかったことと、あと今後の展開に関するいろんなアドバイスをいただいて、これからも頑張ってこのコンセプトを発展させていきたいなと思います。ありがとうございました。
はい、おめでとうございます。では2件目の方のエモーション。こちらの、発表者の方、前の方へお願いします。
インタラクション2018インタラクティブ発表賞一般投票、林様、鈴木様、貴殿が本学シンポジウムインタラクション2018において発表されたエモーション、一つの絵を描くだけで誰もが容易にさまざまなポーズの絵を描くことを可能にするツールは来場者による一般投票で好評を博し、今後のインタラクション研究に一石を投じうる魅力的な発表と認められました。よってここに表彰いたします。平成30年3月7日、インタラクティブ発表委員長山本剛志郎、おめでとうございます。
体験者の方々に、楽しかったっていう声をいただいて、それだけでただ嬉しかったんですけど、まさかこういう大きい賞もいただいて本当に嬉しく思います。投票していただいてありがとうございました。
はい、おめでとうございました。あとは、最後の3件目ですね。こちらの方の、受賞者の方は、ステージに向かって左手の方へお願いします。
インタラクション2018インタラクティブ発表賞一般投票、松浦様、小泉様、貴殿が本学シンポジウムインタラクション2018において発表されたスクーピリット、水面反射を用いた空中像とのインタラクションは来場者による一般投票で好評を博し、 今後のインタラクション研究に一石を投じうる魅力的な発表と認められました。よってここに表彰いたします。平成30年3月7日、インタラクティブ発表委員長山本剛志郎、おめでとうございます。
ありがとうございます。妖精を展示していたんですけど、皆さん体験されるときに、すごい妖精が生きてるみたいに優しく触っていただけて、すごい嬉しかったです。生きてるみたいに扱ってもらえて。で、今後のアプリケーションとか応用例についても、いろんなご助言やアドバイスいただけて、とても参考になりました。本日はありがとうございました。
こちらで一般投票の方の、インタラクティブ発表書は以上となります。もう一度拍手でよろしくお願いします。はい、お願いします。ありがとうございます。おめでとうございます。
はい、それではですね、インタラクティブ発表賞の、プログラムコミッティ、プログラム委員会による推薦で選ばれた賞というものを発表していきたいと思います。これは3日間を通してですね、すべての発表が、プレミアム発表が対象で、3日間を通して1回発表されるものです。では、いきます。じゃん。1個目が太陽光源を用いたもの。2つ目が、これポスターです。ポスター発表ですが、プログラミングワークショップのものと、無限電気味覚ガム。さらに紙をちぎるやつですね。が受賞します。それと、プラス4件、ドン。ひらがな所持学習における触覚支援手法をラポ投資、これ読めないんですよね。で、バブルスライドと、帯同の計測と帯同の再現が可能な帯同共有システムの提案、以上8件が、プログラムコミッティからの推薦でインタラクティブ発表賞を受賞する、ものになります。それでは、1つ目からもしいれば行きたいんですけれども、太陽光源を用いた液晶シャッターの高速な開閉制御によるやつ、いますか？います。もう橋田先生呼ばなくていいですか？いいか。来ました？あ、来た来た。走ってください。もちろん、はい、よろしいですか。はい、インタラクション2018インタラクティブ発表賞 PC 推薦、中山祐之介様、横田智弘様、はい、橋田智子様、貴殿が本学会シンポジウムインタラクション2018において発表された太陽光源を用いた液晶シャッタの高速な開閉制御により肉眼で不可視な影を投影するディスプレイは本シンポジウム委員会にて厳正な審査を行った結果、革新的なインタラクション研究の方向性を示すものであり、今後の情報処理分野での発展に寄与する優秀な発表と認められました。よってここに表彰いたします。平成30年3月7日インタラクション2018、プログラム委員長坂本大輔、おめでとうございます。じゃあ一括で、はい。
このような賞をいただき本当にありがとうございます。1日目に展示したんですが、本当にいろんな方に見ていただいて、これどうなってるのすごいねみたいな発表だったりとか、あとはすごい今後の展開についての熱い議論などをたくさんさせていただきまして本当にありがとうございました。これからもよろしくお願いします。ありがとうございます。
はい、それでは2件目の、飯塚様、飯塚さん、函館未来大学飯塚さんいらっしゃいませんね。いらっしゃいませんね。いらっしゃらない。はい、いらっしゃらないですね。じゃあ次は、無限電気味覚ガムの発表の方。これ4人いますか？ はい、よろしいですか。はい。インタラクション2018、インタラクティブ発表書プログラムコミッティ推薦、大場様、中村様、青山様、宮下様、以下同文です。おめでとうございます。
はい、PC 推薦の方でも選んでいただいてすごく嬉しいです。明日からもまたいろいろ研究を進めていって、評価されるものをまた出したいなと思ってます。ありがとうございました。
はい、それでは次、紙をちぎることで電子情報を手渡すインタラクション方式の実装の、著者の皆様、どうぞ壇上へお上がりください。はい、準備よろしいですね。はい。インタラクション2018、インタラクティブ発表書、プログラムコミッティ推薦、玉木様、富永様、呉様、宮田様、中村様、以下同文です。ありがとうございます。
先日はちょっといなくてすみませんでした。これはですね、夜な夜な部屋の中でレシートを広げてずっとパシャパシャ写真を撮っているのを冷たい目を見られながら続けていた研究でございます。もう、このような賞をいただいて本当に感謝の、その限りでございます。ありがとうございました。
はい、それでは次の、ひらがな書字学習における触覚化支援、手法の著者の方、いらっしゃいますね。はい。インタラクション2018インタラクティブ発表書 PC 推薦、佐藤様、楊奥様、杉妻様、酒井様、水野様、以下同文です。ありがとうございます。
発表は2日目で、今日実は16時まで筑波で予定があって、この表彰式のためだけに来てギリギリ間に合って受賞できてよかったです。ありがとうございました。
ここから、3日目の、ものになっていくんですけれども、孫さんいらっしゃいますかね。さっきもう帰っちゃいましたかね。帰っちゃいましたね。いますか、あそこにいる。インタラクション2018インタラクティブ発表書、孫四亜様、橋田様、上岡様、はい、以下同文です。おめでとうございました。
ありがとうございます。最近学生と一緒に研究して自分は手を動かさないことばっかりで、そろそろ手が動かしたくなって久しぶり3年ぶりぐらいに研究をシニアのメンバーでやって、すごくドキドキ展示をしたので本当に嬉しいです。ありがとうございました。
はい、続きまして、バブルスライドフリック操作の規則性を高めたスマートウォッチ向け日本語かな入力インターフェースの、方、はい。インタラクション2018インタラクティブ発表書 PC 推薦東條様、加藤様、山本様、以下同文です。おめでとうございます。
このような賞をいただいて大変光栄に思っております。まだまだ可能性のある研究分野だと思っていますので、今回を励みにこれからも頑張っていきたいと思います。ありがとうございました。
はい、それでは最後になりますが、帯同の計測と帯同の再現が可能な帯同共有システムの提案に関しまして、賞です。インタラクション2018インタラクティブ発表賞 PC 推薦小坂様、以下同文です。おめでとうございます。
ありがとうございました。一般投票の部分でダメだった時点で逃したと思ってたんですけど、サプライズでいただきましたのでありがとうございます。インタラクションで賞を実は取ったことがなかったので非常に嬉しいので額に飾ってこれからの励みとさせていただきたいと思います。ありがとうございました。
はい、以上で、表彰式の方は終了となります。引き続きましてクロージングに移りたいと思います。ですね、表彰状を取りに来られなかった、未来大の方、代わりに受け取ってくれる人がいれば、ぜひ持って帰っていただけると嬉しいなと思います。住井先生がいる。
はい、3日間お疲れ様でした。最後、手短に、クロージングをしたいと思います。大会委員長の大内です。先ほど、キーノート、IUI と一緒に、共同開催ということでやりまして、この辺、一橋コードのホールは、ほぼ満席ということでしたけれども、ご案内したサテライトの方もですね、こういった形で、満席とはいきませんでしたけれども、サテライトの方にもたくさん人が来ていただけたということで、非常に、盛況だったということです。ものすごい19階なので、皇居を見下ろすような場所で、非常に景色も良いところで、やりました。はい。で、もう私からは最終的な参加者の数だけ、ご報告します。先ほどIUI のオープニングで土方先生からちょっともうネタバレ的に出てしまいましたけれども、当日の参加者数がまずポイントですよね。これはオープニングでもお話ししましたけれども、事前登録が614名ということで、例年と同じくらいの規模で、当日、キーノートの前までに、当日受付されて、キーノート中に当日受付した人がいれば、ちょっと数が変わってるかもしれませんけれども、99名、残念ながら100名はちょっといきませんでしたけれども、当日来られた方が99名ということで、合計700名を超えました、インタラクションとしては、非常に、例年通り、たくさんの方々に来ていただきました。で、IUI には、事前登録で、実際今日何人いらっしゃったかちょっと計測してないんですけれども、371名ということで、正真正銘、今日は1000人を超えたということで、盛大に開催できました。ご協力ありがとうございました。最後、拍手でお願いします。はい。で、気になるのが来年だと思うんですけれども、ちょっと懇親会でばれかかっていますけれども、来年の大会委員長の、斉藤さんから発表していただこうと思います。
ちょっともったいぶってすみません、副委員長をやっております NTT の斉藤です。それでは来年ですね、どこでやるか、いつやるかということを発表しますので、皆さん来年も出る方はメモをしっかり取ってください。来年は期日は3月6日から8日になります。ちょっと曜日が水曜日からなりますので、水木金という形で来ます。日程的にはほぼ同じですね。で、場所はまた同じ場所です。ここです。ここになりますので、引き続きよろしくお願いします。来年また会いましょうということになりますので、忘れずにここに来ていただければと思います。いいですかね。メモ取りましたかね。じゃあ、マイクを開始しますので。
はい、以上をもちまして、無事、インタラクション2018、終了となります。大会委員長としては、怪我人は多分出てないというところが一番安心したところです。ご協力いただいてありがとうございました。撤収も終わってるはずですけど、まだ作業残っている方はくれぐれも気をつけて、作業をしてください。では、以上でインタラクション2018終了とさせていただきます。また来年会いましょう。ありがとうございました。